Hello everyone. In this video we will be introducing the notion of power series. Alright, so what are power series? So basically we're just going to take our regular series and now we're going to think of them as functions. Okay, so they're actually going to take in inputs and we're going to be able to talk about a lot of different series at once. So what do I mean by this? So in general, just the simplest form of one of these would be of the form a sub n x to the n from n equals 0 to infinity. So what does this mean? Well, we've got our a naught, right, because x is 0 is 1, plus a1x, plus a2x squared, and so on. Basically, you can think of it as like an infinite degree polynomial, right? So our an, this is just going to be some sequence, right? These are all constants, our coefficients, and x is a variable, okay? So it can take on any value, and then we can think about different series for different values of x. So more generally, power series are not always of this form. The general form will be an times x minus c to the n. And we call this the power series centered at c. Okay, we'll talk about why we say the word centered in a little bit when we talk about convergence. All right, so let's look at just a couple of basic examples. It turns out that both of these are actually rather important examples when we start talking about Taylor series. So one example would be n equals 0 to infinity of just x to the n. And this is one we'll come back to in a bit. But this is just 1 plus x squared plus x cubed, and so on. And then another one, let's look at one that's not centered at 0, would be n equals 1 to infinity of negative 1 to the n plus 1 times x minus 1 to the n over n. Okay, so seeing the minus 1 here, right, this one is centered at x equals 1 for that reason. And of course, we're starting this at n equals 1 and not 0 because we've got this n in the denominator. So the main question that we are concerned with in terms of series was whether they converge or diverge, right? So we're concerned with the same thing for power series. The difference is we have different values of x, right? So it's not one series at a time, but a series for every value of x. So in this case, one of the three following statements is true. Either the series converges only at the center, x equals c, and it should make sense why it converges at x equals c, right? Because every time we plug in c for x, we're getting 0 in there. And so only your a0 is even a potentially non-zero term. So it's definitely going to converge. It's just a finite sum of one term. Another option is that series converges for all values of x. And then the third is the most interesting one. So here we have some positive value r, where the series is going to converge inside this interval from c minus r to c plus r, and diverge outside it. But notice that I only say x less than c minus r or greater than c plus r. It tells us nothing about the endpoints. So those are basically left for us to do a little bit more work. And you can see now also why we call c the center, because really it's the center of this interval for which our series is going to converge, right? So we'll have radius r around c, and basically we know that it's going to converge inside, it's going to diverge outside, and then we just have to do a little bit more work to figure out what happens at our two endpoints. And so this is a good time to talk terminology a little bit, right? So again, c is our center, r is what's called the radius of convergence, and then whatever you end up with this interval, this is going to be the interval of convergence for our power series. So now let's go ahead and look back at, for instance, our first example and see where it's going to converge. All right, so our first series was the series n equals 0 to infinity of x to the n. So how do we determine when this is going to converge? Well, notice that what are we really doing here? We're multiplying by x every time. This is always a geometric series, right? And in this case, our r is actually just equal to x, right? And since we start at n equals 0, our first term is 1, right? And so our a is 1. But to determine convergence, well, we already know the answer for geometric series, right? So if the absolute value of x is less than 1, this converges, and otherwise it diverges, right? Because we actually know the endpoints here, right? So this would basically mean our big R is 1, our center here is 0, right? We just see x, not x minus something. And so our interval of convergence here would be -1 to 1. And we know that it really does not converge at the endpoints, because if the absolute value of r is greater than or equal to 1, then we know a geometric series diverges. Okay, so let's look at another one, maybe one that's a little bit more complicated. So let's look at n over 3 to the n times x to the n. All right, so this is not geometric anymore, right? Because we have the n here. Otherwise, everything else is to an nth power. And likewise, we don't really want to use like a root test because not everything is raised to the nth power. So what we can do here is the ratio test. Okay, and in this case, we are not guaranteed positive terms, so we should be looking at the limit as n approaches infinity of the absolute value of our n plus 1th term over our nth term. So in this case, it's going to be n plus 1 over 3 to the n plus 1 times x to the n plus 1 over n over 3 to the n times x to the n. Right, and of course, fraction over fraction looks a little nasty, so let's go ahead and rewrite this by multiplying by the reciprocal. So we have n plus 1, x to the n plus 1 over 3 to the n plus 1 times 3 to the n over n x to the n. All under absolute or inside absolute values. So we can get some cancellation here, right? So 3 to the n and 3 to the n plus 1 leave just a 3 in the denominator. Similarly, we have just an x left on top. And so rewriting this, we see that we just get the absolute value of n plus 1x over 3n. Well, what's going to happen here, as n goes to infinity, the n plus 1 over n is just going to 1, right? And so this is just going to be the absolute value of x over 3. Now, what does the ratio test say? It says if whatever ratio you end up getting is less than 1, it converges, otherwise it diverges. So our power series converges if the absolute value of x over 3 is less than 1. And when does this happen? Because we want to know about x itself, right? Not x over 3. So this would be when the absolute value of x is less than 3. And so our radius of convergence then is exactly 3, right? This was another one centered at 0, and so basically we're saying if the absolute value is less than 3, so if we're in here from -3 to 3, it's going to converge. And we're not going to worry too much about the endpoints right now, but we will end up looking at that later. So let's look at one more where our center is not 0 this time, right? So here our center is at 10, so we have the x minus 10 to the n. We see a factorial showing up, and again, we want to be doing the ratio test here, and this is usually what we're going to be using for power series. So in this case, what do we have with the ratio test? So we'll have the limit as n approaches infinity. Again, we want to have absolute value. We actually do not have a fraction over a fraction this time, so we can just take care of it in one fell swoop here. So we'll have -1 to the n plus 1 times n plus 1 factorial times x minus 10 to the n plus 1 all over our original term, so -1 to the n factorial x minus 10 to the n. And again, we get some nice cancellations, right? So we're left with just an x minus 10 on top. We're left with just an n plus 1 on top. And basically, this doesn't matter. Yes, we're left with a -1 on top, but we're inside absolute value, so we don't really care about minus signs here. So ignoring that part, we are really just looking at n plus 1 times x minus 10. And what happens to this as n goes to infinity? Well, for any value of x, right, this is going to be some finite number. Could be very large, but it's still finite. And so when we're multiplying by something going to infinity, our n plus 1, this is always going to end up being infinity. And so this actually diverges for all values of x except for, of course, 10, because in that case, right, you're just adding 0 over and over. So this diverges for x not equal to 10. In this case, we would say that our radius of convergence is 0, right? Because if we look at our picture, like we've got 10 here, and then that's the only point, right? So we have like a 0 radius interval around it, and no real interval of convergence. It's just the point 10. All right, and so we have 2 exercises here. I just want you to find the radius of convergence for these 2 series, for these 2 power series. All right, thank you for watching.